Hi, this is Maggie. In this video we're going to solve a problem that requires branching and logic. Before we get started, I'm going to quickly give you some tips for how to get the most out of this video. First, if you have problem solving with Python, read up through chapter 3. If you don't have it, you can still learn a lot from this video. Open up idle and follow along with Python as I work. Sometimes I'm going to suggest you pause the video and complete some steps on your own. When I do that, pause the video and do your best to complete the steps on your own. The way to learn to program is by programming. You can watch and learn if you work along with me. Remember, you can always pause the video and try something, or go back and watch again. You don't have to wait for me to tell you to pause. There are some automated exercises in the description of this video. The exercises work with the same code or similar code to the code in the videos. After you've completed the video, try the exercises to cement the concepts in your mind. Now let's get started. We're going to solve a problem for a friend who has to travel frequently. They have a basic packing list of clothes and other essentials, but they would like a program to remind them of what else they need to pack based on whether they're flying, taking the train, or driving, and whether they will need to be outside frequently during the trip. If they're flying, they want to be reminded to pack headphones and reading materials. If they're taking the train, they want to be reminded to pack earplugs and a water bottle. And if they're driving, they want to be reminded to pack sunglasses. If they're going to be outside frequently, they want to be reminded to pack sunglasses, walking shoes, and an umbrella. To solve this problem, we should follow the problem-solving steps that we know, beginning with understanding the problem. Pause the video, review the problem description, and think about what you do and do not know about this program. Write down some questions that you would ask the friend who has requested this software. Pause now. Did you come up with some questions for our friend? I'm wondering mostly what they want this interface to look like. I would mock up some examples of the program executing and ask them which they prefer, which leaks into the identifying and selecting among solutions steps in the problem-solving process. For example, the program might look like, are you traveling by plane, train, or automobile? Plane. Will you be outside frequently during the trip? Yes. This example doesn't give the user a lot of hints about what they should type. Do they type out the full word automobile, for example? Would the program recognize uppercase letters, lowercase letters, or both? Should we give more hints, like, are you traveling by plane, train, or automobile? Type the full word, all lowercase, plane. Will you be outside frequently during the trip? Type yes or no, all lowercase, yes. Or should we allow single letters, like, are you traveling by P, plane, T, train, or A, automobile? Type the first letter of your answer, A. Will you be outside frequently during the trip? Type Y for yes and N for no, Y. Or should we ask a series of yes-no questions, like, are you traveling by plane? Yes, no, no. Are you traveling by train? Yes, no, no. Are you traveling by automobile? Yes, no, yes. Will you be outside frequently during the trip? Yes, no, yes. And what if they answer yes to 2 or more of the traveling options? We should meet with our friend, talk about exactly what the inputs and outputs would look like for these different interface choices, and identify any problems and how they should be handled, such as the user entering Y instead of yes, or the user entering yes for more than one mode of travel. Maybe they're taking a car to the plane. Ultimately, you and your friend decide that you will build a program with the interface with this series of yes-no questions. And the user will type the full word, yes or no. The program will accept only lowercase, yes or no. If the user doesn't type yes or no in lowercase, that is, if they type some other word or mix the case, it should be interpreted as a no. The program should not print out any duplicate items. So, for example, if they answer yes to both automobile and outside frequently, the program should not print sunglasses twice. Looking carefully over the options, sunglasses is the only item that appears in 2 places. To make sure we fully understand this program, we should determine the output for all possible combinations of inputs to the program. That often isn't possible, but because there are only 4 inputs, and only 2 possible values for each, with non-yes-no values considered to be no, then there are only 16 combinations of inputs this program will have to process. Pause the video and list all the possible combinations of inputs and the appropriate output for each one. Pause now. How'd you do? Did you find all 16? Did you think of a methodical way to write them out to ensure a thorough process? I decided to make a table and highlight the elements that would be chosen and printed. Because there are only 2 options for each column, it's like the binary numbers from 0 to 15, where bold is 0 and plain text is 1. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, etc. So the first row is a yes to everything, illustrated by all output being bold, except for the second sunglasses. So for a yes to everything, we expect to tell our friend to pack headphones, reading material, earplugs, water bottle, sunglasses, walking shoes, umbrella. Our next option is yes to everything except outside. Pack headphones, reading material, earplugs, water bottle, sunglasses. Then yes to everything except automobile. Pack headphones, reading material, earplugs, water bottle, sunglasses, walking shoes, umbrella. And we continue in this way for all 16 combinations of yes or no answers to each question. We now know exactly what the output should look like for every single input, and we can use this table to test our program as well. Now, moving through the problem-solving steps, we have understood the problem. We have expressed different interface solutions and chosen among them as part of refining the problem. Because, again, we're programming the solution in Python, and we haven't learned a lot of Python yet, we don't have a lot of different options for how to solve this problem. We don't yet have the option to read and write from files on the hard drive, for example. We know we're going to create a text interface because we don't know how to create a graphical user interface. We're writing a desktop application because we don't know how to write a phone app. Once you've learned more programming, expressing solutions and choosing among them will be a much bigger and more interesting step. Our options for different solutions to choose from will have to do with design decisions about the data we store and the structures we put in our program to construct a flow of control. Let's think for a moment about what sort of structure our program must have. We're going to print lists of items or not, depending on the user's answer to questions, so we will need a decision structure of some sort, or if statement. It would be pretty easy if we could check for a yes answer to each question and then display the items for that mode, if we have a yes, but we have to be careful about car travel and outside activity, as both activities include sunglasses on the list, and our friend doesn't want duplicate items printed out. So we can check for plane and train individually and print those items out, but then we must check car travel and outside activity together, which will involve slightly more complicated logic. So let's move on to implementation. I'll open up a window from the idle console and I'll flesh it out with some comments. Obtain answers to travel questions from the user. This is where we'll ask the questions about how the user is traveling and whether there will be a lot of outdoor activities at the destination. Once we have those answers, we can determine what should be packed based on travel answers. And display the packing list to the user. With this structure in place, and with our good understanding of how the program should work, you should pause the video and write the code to annotate some variables and obtain the travel answers from the user. Remember that our friend endorsed an interface like this. Are you traveling by plane? Yes, no. Are you traveling by train? Yes, no. Are you traveling by automobile? Yes, no. Will you be outside frequently during the trip? Yes, no. We should use the question text that our friend signed off on. Write the variable annotations and the input statements and test to make sure that your variables contain the correct input and are of the correct type. Pause now. How'd you do? Your first decision was the name and type of the variables for the user inputs. The user will be entering yes or no, so the type is string. They're entering text that we are interpreting as text. For variable names, do your variable names follow the Python conventions, and especially do they relate to the problem being solved? I'm going to name mine plain underscore answer of type string, str, train underscore answer of type string, car underscore answer of type string, and outside answer of type string. These clearly relate what the user types to the problem being solved. For the input statements, I'll write plain answer equals input. Are you traveling by plane? Yes or no. And I'll add a space before I close the quote, so there's some space between the prompt and where the user enters yes or no, and then close paren. I don't have to cast that to a string because an input statement returns a string. We only need to cast to a numeric type if we are asking the user for a number. So I'll write the 3 additional input statements, and I'm going to pause this recording and come back because you don't need to watch me type that. There. Now we need to test that. It's important that we have the correct answer associated with the correct variable, so do a visual check that your prompt matches up with your variable name so you don't accidentally write bad code later. Remember, the user isn't seeing your variable name. We check that the name is meaningful for the programmer. Imagine if I had called these answer 1, answer 2, answer 3, and answer 4, for example. That's tempting, but it means that later when I want to figure out what to put in the packing list, I have to remember which one of those is the car answer, for example, or I have to go back to the input statement and check. If I call the variable car answer and I've tested to make sure the user's answer to the car question is being stored in that variable, then I've made my job as programmer easier, and I've made it easier to read and modify this code in the future. So we'll run it. And at each prompt, I'm just going to write plain, train, car, and outside, because we don't need a yes or no answer to test this. We haven't gotten that far with the program yet. This allows me to quickly check that the train variable holds the answer I gave to the train prompt, which is train. So in the console, after running the program and typing those values in, I can check the value in plain answer, train answer, car answer, and outside answer. And I can see that they're the correct words. And I can also see that they're the correct type because they're enclosed in quotes. We've successfully obtained our input from the user using the interface requested by the client, our friend, and we can move on to the interesting part of this, figuring out the output. I want to start by working with one of these answers. Let's say the plain answer, the first question we ask. If the user types yes, all lowercase, we want to add headphones and reading material to our packing list to display to the user. If they type anything other than yes, we won't add those. So we do one thing for a yes answer, and we don't do anything for any other answer. That means we only need to check for yes. Should we append our results into a result variable, or just print out directly? If we print out directly, then the code will be under these 2 comments: determine what should be packed based on travel answers, and display packing list to the user. If we want to append results into a variable, then we would do that first, and at the end, after we've completed the list, we would display it to the user. Pause the video and choose one of these strategies. Either create and annotate a packing list variable, or directly display the result. Determine whether the user has entered yes to the plain question, and print out the correct packing list based only on the answer to that question. Test your result. Pause now. So how did that go? Let's look at the two different strategies, starting with doing both steps in one, determining what to pack and displaying it all at once. How do I determine what to pack based on the user's plain answer? I have two options. Either they typed in yes, and I'm going to tell them to pack headphones and reading material, or they typed in something else, and I'm not going to print anything. So I'll use an if statement with the condition if plain answer is equal to yes, and remember that when we're testing for equality, we use two equal signs. So if plain answer equals yes, colon, and then on the next line, I'll print the packing list. I can use two print statements, print headphones, and on the next line, print reading material, and we can test that. Before we test it, I'm going to comment out the other questions to save time. I'm going to select those statements and choose Comment Out Region from the Format menu. Now to test, I want to test a yes answer, all lowercase, and I want to see my packing list if I type that. I should also test a no answer, and I should test anything other than lowercase yes and no, such as uppercase yes. If the user types anything except lowercase yes, I expect nothing to print. So I'll run that 3 times, once with a yes, and I get my packing list, once with a no, and no packing list, and once with a yes with some uppercase letters, and no packing list. So that if statement works just fine. Now we could continue the program this way. We could also do this in 2 steps. Accumulate the results into a packing list and then print it. I'm going to now change it to accumulate a list, and the reason I prefer this method that I'm about to implement is because it separates processing from communicating with the user. That way, if we change either the processing or the communicating, they're distinct and therefore easier to change. So I'm going to annotate a variable called packing list of type string, and I'll initialize that to the empty string. And if plain answer is equal to yes, I'm going to append headphones and reading material into the list with a new line separating them. So packing list plus equals, that means I'll be adding to what's already stored in the variable, which is an empty string. Quote, headphones \n reading material. So that belongs under the comment determine what should be packed based on travel answers. And I'm going to move the other comment below that, display packing list to the user, and under that comment I'll print the packing list. And if I quickly test that with the same 3 tests, yes, no, and yes with uppercase letters, I get mostly the same result. Notice that the program does always print the packing list, even if it's blank. So I could add an if statement here. If packing list is not equal to the empty string, print packing list. And that way, it won't print anything if it's the empty string. If I test that again and type in no, it doesn't print that blank line. Okay, so now let's add the 2 other travel options. See if you can work with this version of the program and not the one that prints immediately after an if statement. We're not going to worry about time spent outside yet. Remember, that interacts with the car travel. Pause the video and add the code to check for a yes answer for train and car travel and add to the packing list. And remember to uncomment the input statements and test your result. Pause now. Okay, were you able to add that code? Did you test it? Remember that you can pause the video at any time, so if you ever aren't able to write working code and I start to write code and it gives you an idea, pause the video and see if you can complete the step. So I'm going to uncomment the train and car questions by selecting them and choosing uncomment region from the format menu. So I will have values in the variables train answer and car answer, and then in the section where I'm determining what should be packed, I'm going to add 2 more if statements. If train answer equals yes, colon, and then indented on the next line, packing list plus equals, quote, backslash n, earplugs, backslash n, water bottle. Next line, if car answer equals yes, colon, and then indented on the next line, packing list plus equals, backslash n, sunglasses. Now, I don't need to change the display part of the program. It's going to print out my packing list, which will have items in it for up to 3 different modes of travel. To test thoroughly, I should test the 8 combinations of plane, train, and automobile. Yes, 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 no, yes, no, yes, yes, no, 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 yes, yes, no, yes, no, 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 yes, no, 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 and I should test some non-yes, non-no answers as well, which my program should process as no. However, to save time, I will test only 2 options here, and I'll test the rest off screen. I'll test yes, 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 and no, no, no. So for yes, 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 expect the program to print the full list from headphones through sunglasses. And it does. And for no, 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 I expect the program to print nothing, and it does. So let's talk for a minute about some decisions that were made here. First, I'm using 3 separate if statements and not another construct such as an if, elif, or an if, elif, else. We only use a single if construct with elif or else if our options are mutually exclusive. In other words, if plain answer being yes meant the other 2 answers had to be no. When we discussed this with our client, our friend, they told us that the user could choose more than one mode of travel. So we need to check all 3. The other issue is the new lines. We're inserting new lines between each item in the list so that each item will be on its own line. However, if the user answers no to plain and yes to train, our output begins with a blank line. Maybe when you produced your output, you avoided this problem. If not, think about how we can print new lines only between our items and not before or after. Pause the video and solve this problem. Pause now. Did you solve the problem? This will be an easy problem to solve when we have more programming tools, but we can still solve it with what we now know. We could print a new line at the start of our packing list only if the packing list isn't empty. That means more checks for an empty packing list each time we're going to add items. So under if train answer equals yes, we'll add a nested if statement. If packing list is not equal to the empty string, add a new line to it. Remove the new line from the start of the packing list items, and we'll add a similar line of code under if car answer equals yes. So if you imagine the user says no to plane and train and yes to car, we have an empty string in packing list. We check to see if plane answer is yes, and it isn't. So we skip the line of code that adds headphones reading material to packing list. We check to see if train answer is yes, and it isn't. So we skip the second whole if statement block. Then we check if car answer is equal to yes, and it is. So we then check if packing list is empty, and it is. So we don't add a new line, and our packing list becomes just sunglasses. But if either of the two conditions above were true, it would not be empty, and we'd put the new line in before we added sunglasses. There's just one more piece of this puzzle to solve, and that's adding sunglasses, walking shoes, and umbrella if the user has answered yes to the question about outside activities, but just add walking shoes and umbrella if we already have sunglasses in our list. I'd like you to pause the video and add the final code. Uncomment the outside answer input statement and add a test or tests so that we get the correct packing list without a duplicate for sunglasses. Then test your solution, of course. Pause now. Okay, so this is possibly our trickiest code. Did you solve it? I'll first select the input statement and uncomment it by choosing Uncomment Region from the Format menu. Now, there are different correct ways to write the logic here. What I want to do is look at the output I get for the different combinations of these two variables only. So I'm going to create another table. This table has just two columns, automobile and outside. And because there are two variables with two possible values each, there are four options. Yes, 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 no, no, yes, no, no. When I look at the output for those four possibilities, I see that the output is sunglasses, walking shoes, umbrella, if outside is yes, regardless of the value in automobile. So I only need to know if outside is yes to give that output. I'm going to make that one condition. If outside answer equals yes. And I'll add all three items to the list. Now, if outside is anything other than yes, then I'll add sunglasses if automobile is yes. That's a mutually exclusive situation. I only add sunglasses if outside answer was not yes. So that requires an elif. I'll write elif car answer equals yes, and I'll check packing list, as with all others, and add only sunglasses. I think a comment will make this clearer. So above this if elif, I'll explain that there is overlap in the items being packed, so these are considered together. And of course, we should add a docstring at the top describing the program. And I'll test that on these four cases here. And because the program is complete, all of the cases off screen. For all four cases, we get the correct output for sunglasses, walking shoes, and umbrella. And that is this problem solved. Now again, there are other ways to solve this. You want to select a solution based on correctness first, of course, and then readability. If you know the program could be modified some way in the future, for example, if you know these lists of items might change, then you might select a solution that you believe will be easy to extend in the specific way you know it might be extended. For example, we might store these item lists as constants at the top of the program, as that will make them easy to find and change if the requirements change. So congratulate yourself. You've written a complete program requiring some interesting logical decisions. I recommend that you close your script window, open a new one, and rewrite the program yourself from scratch. Check back with the video or the program you wrote earlier only if you get into trouble you can't get out of. Once you've completed that, you're ready to move on to solving your own branching problems.